Thank you, Noel. So yes, before I want to talk about the future in analytics, I simply want to kind of a little bit summarize what we have seen today. In the morning we have seen basically it's very easy nowadays with IoT devices to simply get data out of your systems and push them into the cloud. So, and we actually have learned in the last session that basically you even get the meter for free. So it's very easy nowadays to set up your equipment, create data, and analyze the data. And we also have seen what we have done with the Tesco data, that actually it's very easy to get very good insights out of your historical data. So the moment you create data, you get good insights how you can optimize basically your business and improve basically the operation, such that like in the case of Tesco, they save 33% of the energy bill. So it's really a huge amount of money we're talking about. And the last thing basically with the demand response, you also have seen with the future, with the flexible energy market, you actually have the need to be reactive and shift your loads around, because then you even can save more. And that's basically the only thing that you actually need to do this is you need some people, maintenance people, that, by the way, also are professors in statistics or worked on analyzing brain images, and that can deal with all this data. So I only got basically two good messages for you. The first one is, we are here to help. So, and the second message is that we're actually working on systems that don't need experts to operate, but that actually using cognitive technologies, so self-learning technologies, to analyze the data, process it, and provide you the insights that you need to operate your business. And that's actually what you will see here. So it's basically an approach that allows you to understand how your energy consumption works, how it worked in the past, and for demand response, also predict how it will be tomorrow and the day after. And we have seen that basically also in the presentation from Bay, that basically if you want to predict the energy consumption of your store, you're not talking about simply taking the consumption of yesterday and projecting it on tomorrow. So you actually have to consider the weather, you have to consider what is the effect of customers coming in and buying stuff, and you have many contextual basically information that you have to consider simply to predict how will your energy consumption be tomorrow, and then also to analyze and detect abnormal consumption. So nowadays you kind of basically need an operator that has this feeling for this. So who understands like what is the store consumption, how will it be tomorrow, and then he will be able to identify, for example, outliers. But you also have seen in Tesco case, they have energy managers for each store. But in the end, basically, these managers are even not basically able to process all the data coming out of the store. So they need systems to help them and to point them basically to the anomalies that basically are occurring in the store. And that's basically what we do here. So we have a system that basically takes historical data of the store and automatically learns models for the energy consumption. So, and it considers all the different factors that you will need to consider. So it considers weather, it considers occupancy, and it basically also considers if you have it available, for example, the buying behavior of your people in the store. So, and you basically put all these information into your model, and then it will learn how the energy consumption basically behaves. And the big benefit of this model is, it's not some kind of black box model nobody understands. So it's actually a transparent model. So it's basically a model that creates transfer functions, like you have seen basically earlier. And you can interpret these transfer functions. So you, for example, have a transfer function for Friday, and you actually see your energy profile for Friday, and you see basically the dependency on the temperature, and the dependency on the solar radiation, the humidity, and all these different factors. And we're using basically these models then to create a prediction for the next day. And then we can compare over the day the real consumption against basically this predicted energy consumption. The benefit of the prediction is you can use that for demand response. So if you want to shift your load, you actually need to know when is your load occurring. And we actually can predict this. So we take in basically all the data, and we can tell you when your peak on the day is. And then you can easily shift it around. And also basically it allows us to easily detect anomalies in the data and the consumption. And the last step is we don't do that only basically for the main meter. So we do that for all the meters you have. And that's basically the challenging thing. like in the Tesco data set, so you have to consider, we worked on 150 stores. Each of these stores have about 25 meters. Simply basically have people analyzing every day all these meter data. Nobody can do that. You need a system to do that for you. But if you have a system that does that for you, you actually can use a system to diagnose also where abnormal consumption is coming from and point you basically to the aspects that you have to solve. And that's what I'm going to show you and to demo you. So this is basically our interface for the DE diagnoser. What you see at the moment, I'm just switching here to a time series. So you have here a calendar view showing the historical, basically a calendar of the energy consumption for one store in the past. And you can see here there's some orange dots where there are some anomalies occurs, but in general, basically the energy consumption of the store seems to be quite normal. So, and basically if you go to the stores and to the data, for example, you will see basically even if it's kind of looking quite normal, by simply switching between the days, you actually see that there's something like a regular pattern that you as human would expect. So because the energy consumption depends on too many factors that you even as human, it's very hard for us to guess and understand it. So, but the algorithm actually can understand that. And it allows us to detect, for example, anomalous behavior. Like here. So you see here basically our prediction says that the store energy consumption shouldn't exceed 125 kilowatts, but it does. So something went wrong here. And the question is what? So if you simply look into the energy flow, then you would say, okay, we have our refrigeration cases down here, and kind of if you compare that basically to a previous day, so if you go basically to a previous day, you see it kind of looks similar. So there's not much basically what you can learn if you simply look on the aggregated level. So you need more insights if you really want to identify where this anomalous consumption is actually coming from. So and that's basically what the diagnoser does. So it basically analyzes the consumption between basically all the sub-meters and identifies when you have an anomalous consumption where it's coming from. And you can actually see here that there was one of the high cases was incorrectly scheduled and was operating all the time, which it shouldn't. And with this basically system, we could directly identify. So there's something incorrectly going on with the schedule of this with the high case, and we could have sent in somebody, a maintenance guy, to solve this problem. And basically 1 week later, so the whole thing basically was solved. So. And the benefit about the system actually is that it is using basically these kind of transparent models that you can easily interpret, and these models are self-learning. So you don't need basically a statistic PhD to tweak the model to your data, and you don't need basically much experience to trust the model. You actually can see how the model is created, and the model is basically adapting itself, for example, to change points in the behavior, to different weekdays, and to external influences like the temperature, solar radiation, and humidity. And last but not least, you can simply take this information and say, okay, let's create a work order. And I can simply basically create a new work order Maximo and have a maintenance guy directly solving my problem half an hour later. And that's basically the big benefit when you take IoT data. You can easily instrument nowadays your systems, and then basically with cognitive self-learning approaches, you can easily create models that help you to detect and solve the anomalies in the behavior of your operation. And that's basically what I wanted to show you. And the last thing it actually is, coming back to my slides, is that's another thing we're currently working on, is you not only can do that on store level, you actually can do that to benchmark all your stores. So that's basically what we have done here. So you basically, we create all these models for all the stores, and then you actually can identify which of your stores are highly dependent on the outside temperature, which of the stores have some problems basically in the general scheduling and operation because they're basically depending highly on the time. And this all basically, normally when you try to benchmark your stores, you have to consider so many facts like the size of the store, the type of the store. In this case, basically, you can take the model to separate all these different influences, and then you can easily see which of your stores are behaving basically anomalously and where you basically have to invest first to improve the energy consumption of the stores. And that's basically what you can do with data. And you don't need to be an expert in this, because we already have the experts hired for you. So do you have questions?
Yeah. So how much does it cost?
I think we should talk about this half an hour later. No, but the point here is and that's what we've seen with IoT systems, as you push all the data in the cloud, and we have heard that earlier. So when you have the data in the cloud, you can easily scale these systems. So we're not talking here about very expensive systems, because actually these systems are very scalable, quite easy to set up, and that's why they're also not expensive. How expensive they are, that's something we have to talk about in private.
Okay, Joern, thank you very much.